page, we're going to go to your notes first. We're going to do one proof today. And we're doing this proof because it's a proof of a theorem. And remember the difference between a theorem and a postulate. We have to prove the theorems. So we're going to prove the first one, but that's the only one I'm going to make us prove today. What's your first step in a proof? Good. Write your given down then. Yeah. No, that's weird. Well, I delete them after. I'll delete all mine after this year. Ask that again. Yeah. This symbol means parallelogram. Like a triangle, we use triangle symbol. Circle, we use circle. For a rhombus, a square, and a rectangle, we don't have symbols. We just have to write out like rectangle A, B, C, D. But that is your parallelogram symbol. Good. What do we know about parallelograms? No, they don't. Yeah, they have both pairs of opposite sides are parallel. So that's what you mark then after you write your given. We're trying to prove that AB is congruent to DC, or the left side and the right side, and BC is congruent to DA, the top and the bottom. Okay. I threw a diagonal in there, and when I put that diagonal in there, what did our parallelogram turn into? Two triangles. So if we think about this in relation to the triangles, we're trying to prove that one side of a triangle is congruent to the other side of the triangle. And this side of the triangle is congruent to this side of a triangle. Remember, sides of triangles are their parts. So we're trying to prove that parts of the triangles are congruent. That's exactly what it is. But before I can use CPCTC, what do we have to do first? Yeah, prove that the triangles are congruent to each other first. So that's what our goal is right now. We have to prove that those two triangles that we can see are congruent. Oh. What do we know? Yes, you can use the numbers. AC is congruent to AC, Trevor said. Anything else? You might want to write kind of small. It's 5 steps. Alternate interior angles. Which ones would be alternate interior? You guys agree with Spencer? Would that give us enough information to prove that the two triangles are congruent? Which of our 5 ways? Good, angle, side, angle. So let's write that down. I think some of you already started. AC congruent to AC. Number 3, angle 1 is congruent to angle 4, comma, angle 2 is congruent to angle 3. If lines are parallel, alternate interior angles are congruent. Step 4 then, triangle ABC is congruent to which triangle? CDA, good. And that would be by angle, side, angle. There. Yep, and then therefore AB is congruent to DC, comma, BC is congruent to DA. Bless you. Because corresponding parts of congruent triangles are congruent. Okay, so now we have to step back and look at it through a wider lens, because we're not talking about triangles really anymore. We're talking about quadrilaterals. So given to us, ABCD is a parallelogram. What do we prove about the parallelogram? What did we prove about it? Okay, what parts? What? Well, it was given that it was a parallelogram, right? And then we just proved that AB is congruent to DC, and BC is congruent to, yeah, its opposite sides are congruent, the parallel ones. That's your first theorem, 6.1. Do you see it right below your proof? Theorem 6.1, opposite sides of a parallelogram are congruent. I just blacked it out up here too. That's the first property of parallelograms. That's what goes behind letter B on your quad tree. So on your quad tree, behind letter B for parallelograms, right, and it's up here in red, both pairs of opposite sides congruent. Or I guess you could just write opposite sides congruent too. I'm going to shorten it up. The definition of a parallelogram is that its opposite sides are parallel. From there, we get all these properties. The opposite sides are congruent. Next property, both pairs of opposite angles are congruent. I'll come back here. If I go back to this first proof, we proved that the triangles are congruent. Therefore, all their corresponding parts are. So that would mean angle B would have to be congruent to which angle? In this triangle, D, right? And if I put BD in as a diagonal, I can prove that the triangles are congruent. And then A would be congruent to C. So to prove theorem 6.2, opposite angles are congruent, you would use triangles just like we did on 6.1. I'm not going to make you do that. But that's how you would prove that. Your last property is that the diagonals bisect each other. Does it mean to bisect? Good. So the diagonals are going to intersect and cut each other in half. Not each of the four are the same length. It's 2 and 2. So now you should on your quad tree have A, B, C, D all filled out for parallelograms. And that's all that we're going to fill out for today for that. So you can leave it out. I'm going to skip the next theorem for right now. We're going to come to it. We're going to go down to the bottom where it says consecutive angles of a polygon. And then you got a big blank line. Consecutive angles of a polygon share a common side. What's the word consecutive mean? Okay, how about this? Give me consecutive days of the week. Good. Monday, Tuesday, Wednesday, as opposed to Saturday, Monday, Thursday. In order, one after another, consecutive one after another. So they share a common side, but you could also say that it's one after another. Okay. Angle M would be consecutive with angle J. It comes after, J comes after M, right afterwards. They both share JM. So there's the share a common side, consecutive one after another. M is consecutive with L. It's one after another. I'm just going counterclockwise around. But they both share ML. So M is consecutive with J. It's also consecutive with L. They'll have two consecutive because they go on each side. Would M be consecutive with K? No, it would be what to K? Opposite, yep. M and K would be opposite, and J and L would be opposite. Okay. What did we learn about opposite angles? Louder, Spencer. Good. So would you agree that M is congruent to K and L is congruent to J? Okay. And this is still a parallelogram. Okay, I don't have it marked, but I'm going to tell you that. What would you know about J and M and their angle measures? Why? Good, they're same side interior. Since this thing is a parallelogram, two parallel lines cut by a transversal means that we have same side interior angles. So they have to add up to what? Did you already say that? Okay. What other angles add up to 180 then? Good, K and L would have to add up to 180. Any other ones? J and K. Any other ones? M and L? What do you notice about these angle pairs? They're same side interior, but how else can we classify them? Consecutive. Good. Right below where I wrote all those equations, it says if consecutive angles of a quad are supplementary, must it be a parallelogram? This is just a quad. If the measure of J plus the measure of M equals 180, if these two angles add up to 180, what would you know about JK and ML then? They'd have to be parallel. That's that blue poster. If same sides are supplementary, then the lines are parallel. If M and L are supplementary, what would you know about JM and KL? They're parallel. So if your consecutive angles are supplementary, does it have to be a parallelogram? Yes. Yeah, consecutive supplementary angles mean you have a parallelogram. If you want to add to your quad tree bullet E, I don't know how you would say that, tab E, and write consecutive angles supplementary, maybe behind it write same side interior, you sure can. That is your aid to help you through this chapter, help you remember all this. Your consecutive angles are going to be supplementary. All of these properties that we filled out are true for rectangles, rhombuses, and squares, because rectangles, rhombuses, and squares come from parallelograms. That means they get all these traits. So opposite angles are congruent. Well, that's true in a rectangle. You can see that. But it's also true in a rhombus. Diagonals bisect each other. That happens in rectangles, rhombuses, and squares. So we're not going to list them all because we've already listed them up here in the parallelogram. I like to think of this as like the parent, and then these are the children's, and then the children's children, but then that's incest, so it's kind of weird, but well, it would be. But you know what I'm saying? Okay, so you get your parents' traits, and then so on and so forth, so it trickles down. Cool. Let's put this into action here. Number one on the top side. Top of the back side, sorry about that. Use parallelogram KMOQ to find the measure of angle O. Since it's a parallelogram, you can mark things on your picture to help you remember that, just like when you're doing proofs. Parallelogram means that the opposite sides are parallel. Then we just listed 3 or 4 properties of parallelograms. What else do you know about them? Don't jump at once. What's bullet B say on your quad tree? Good. So like the top and bottom are congruent, and then the left and the right. What's bullet C say? So Q and M would have to be the same, and O and K would have to be the same. How about E? Because I don't have diagonals, so I don't really care about D. Consecutive angles are supplementary, so like K and M or M and O, the ones next to each other would have to equal 180. What can I use to find the measure of angle O? Why, Brian? Good. Which angles are you telling me are same side interior? Awesome. Angle Q and angle O, are those same side interior or consecutive? Therefore, they have to be supplementary. So 180 minus 35. Would you say 145? Good. Gives you the measure of angle O. Number 2. Go ahead and do it. The two angles that we know something about, B and D, would you consider them to be consecutive or opposite? Okay, and what's the property with opposite angles? So what should I do with these two expressions? Good. Did you guys get x equals 60? Okay, and then to find angle A, what do I have to do then? Where did you get 75? Good. Good. Substitute 60 in, and angle B is 75 degrees. Angle A and angle B are consecutive or same side interior, so they have to add up to 180. What did you say it was? 105? Good. All right. Do number 3. E and G, opposite angles again, so set them equal to each other, and you should get y equals 11. I plugged that back into angle E, so 6 times 11 is 66 plus 4, that's supposed to be a 70. Then I marked E congruent to G, so those are both 70, and then F is congruent to H, and they'd have to be 110. Good on the angles? All right, cool. Number 4 tells us to find the value of x and y in the parallelogram. X is representing the length of LA, then we got 7y minus 16, 2x plus 5, and 5y. Together, like KM and LN, what are those crisscrossy lines? What are they in relation to the parallelogram? There it's what? Well, they do intersect two parallel lines. Good, they're your diagonals. Those are your diagonals that go corner to corner. I probably should have just said corner to corner. What do the diagonals do to each other? What's it mean to bisect? Okay, so KA then is going to be congruent to what? And NA is congruent to? Mark that congruent on your picture. Anytime you have diagonals on parallelograms, they're going to bisect each other. So if KA, 2x plus 5, is congruent to AM, 5y, then I just set them equal to each other, right? That's not going to work. So you just set the ones that have x's equal to each other instead. Well, are the ones that have x's congruent? KA and AL. Are those two congruent? How else are we going to do this? X would equal 7y minus 16 from the other diagonal? Okay. Good. Other equation, x equals 7y minus 16. Now you have two equations with two variables. We just spent a week working on this. You can either substitute or eliminate. It's up to you. I think this one sets up nicely for substitution, like Spencer said. So we can substitute 7y minus 16 in for x. And then our new equation is going to say 2 times the quantity, 7y minus 16, plus 5 equals 5y. Don't forget that, plus 5. Distribute your 2 through. 14y minus 32 plus 5 equals 5y. Combined on the same side, negative 32 plus 5. Subtract 14 over what's 5 minus 14? Negative, right? Divide by negative 9, and what's negative 27 divided by negative 9? Good, so y equals 3. What are we going to do to get x? Yeah, plug this back into one of the originals. I'm going to go into the one that's circled because it's already by itself, x is. What's 7 times 3? Minus 16. So x equals 5. How can we check this? Yeah, plug it back into your picture and see if it actually works. What's 2 times 5? Plus 5. 15, so this side is 15. What's 5 times 3? 15, so it works for that diagonal. X is 5, so this length is 5. Y was 3, so 7 times 3 minus 16, that would also give us 5. So each chunk is congruent. Okay, do your next one. Bless you. Bless you. You get b to equal 14. Plug that back into the one that's circled, and you should get a to be 16. Good? Cool. You don't have to flip your paper over if you don't want to, but I'm going to go back to that theorem 6.4. There isn't anything for you to write on yours. It says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So I have these 3 horizontal lines that are parallel, and the far left transversal is intersecting them so that AC is congruent to CE. Since this transversal makes congruent spaces between them, so will the other transversal. But they're going to be congruent to each other on that same line. They don't go across, they stay on the same transversal. And that would work for any of them. I could throw another transversal through here, and the 2 spaces on that blue line are going to be congruent to each other. They don't go across, they have to stay along the same transversal. So knowing that, you should be able to answer the 5th question, or 6th, whatever number it is. It says in the figure, DH is parallel to CG, which is parallel to BE and AF. So I've got 4 parallel lines. Then it says the length of AB equals the length of BC, which equals the length of CD, which equals 2. So all these over here labeled 2 are congruent. If EF is 2.5, they want us to find the length of EH. What are we going to do to find the length of EH? Good, both of these are going to be 2.5. This transversal, they're all congruent. So then these transversals are all going to have the same distance between them, or between the parallel lines. So then just add them up. What's 2.5 plus 2.5? Try again. It's 5. Right? 2 plus 2 is 4, and a half plus a half is 1. Oh, nope, just from E to G. Good question. Yeah, sorry. All right.